Okay, we're going to talk a little bit about a couple different types of lines that we have not really talked about in any of our other videos. We're going to talk about vertical lines, horizontal lines, and lines that go through the origin. So let's start with vertical lines. And a vertical line, all vertical lines are going to have the same sort of equation. It's just going to be x equal to some sort of constant. Now, vertical lines have what we call an undefined slope. And of course, if you'll remember, a number is undefined if you're attempting to divide by 0. Since a slope is given by the rise divided by the run, this literally shows us that we've got no run. So with something like this, a vertical line will literally just be a line that is going straight up and down. It will only have one, it will only, intersect one of the axes. It will only intersect, say, the x-axis, and usually at whatever point that is. So this would be, x equal to a. So this is literally x equals a, and that will be the a0 there is going to be that x-intercept. Next, we've got a horizontal line. Horizontal lines are always given by the equation y equal to a constant. And here, because our y doesn't change, we literally have we've got no rise. It can have a run, but it has no rise. Since slope is given by rise over run, this will have a slope of 0. Oops, forgot to label my axes over here. When I'm graphing this, my graph will look, it will have just a single horizontal line, and it's going to intersect it'll intersect the y-axis at some point here, and it's going to be, x can be whatever it wants, but every single point on that y-axis, x is equal to 0, so it's 0b. That's going to be the y-intercept. It won't have an x-intercept. Last but not least, we've got kind of an interesting but special case. We've got lines that go through the origin. Now, a line through the origin will have a slope. And usually we're going to say, you might be used to saying y equals mx plus b. In this case, it's just going to be y is equal to mx. So we're going to have whatever normal slope we would have. Our slope is m. And the only thing that's going to be really special about that is both the x and y intercept are going to be exactly the same. It's going to go through 0, 0, and for all of our y-intercepts, the x is equal to 0. For all of the y-intercepts, the x is equal to 0. Or sorry, our x-intercepts, the y is equal to 0, which means this is both the x and y-intercept. So 0, 0 is both the x and the y-intercept. So this is where it's really important to understand how slope impacts things. So, I would have my rise and run to whatever this point to whatever this point is. So now let's go ahead and let's give us a couple more concrete examples of like vertical lines, horizontal lines, and lines through the origin. So let's say we've got something where we've got say y is equal to 3. Okay, here y is a constant, which means there's my x, there's my y, and if y can be constant, that literally means y is a constant. X can be whatever it wants to be. This is just going to be a horizontal line right there. 1, 2, 3, and 0, 3 is my y-intercept. Okay, let's say we've got one of x equals 5. All right, let's do that one. Here's my y-axis. Here's my x-axis. And here, instead of y being constant, so y isn't going to change, y can be whatever it wants to be, but x is going to stay constant. So I will just count my way over to 5. 1, 2, 3, 4, 5. And x stays constant. My x-intercept here is 5, and everywhere here along the x-axis, y is equal to 0. Cool. Let's do it again. Only this time I'm going to do something like y is equal to 2/3 x. Now here, oops, my axis wasn't completely straight, so I'm going to redraw that really quick. Now here, I want you to note that this is still our slope-intercept form. We could still think of this as, you know, y is equal to 2/3 x plus 0. That's still valid. So what we're doing here is we're just using our slope to graph. It's going to go through the origin. I'm going to have a rise of 2, 1, 2, for a run of 3, 1, 2, 3, right there. And I can just count this as often as I want. 1, 2, 1, 2, 3, right there. 1, 2, 1, 2, 3, there. So we've got our pattern right here. Now, if this is a little bit too, if this sort of counting out your slope is a little too fast a thing for you to do, I would suggest, if it helps, go ahead and make up a table of values. As always, whenever you've got the denominator here, here's my x, here's my y, and choose some multiple of your denominator. So if I choose like a -3, no, y is equal to 2/3 times -3. 3 goes into -3, -1 times. 1 times 2 times -1 is going to be -2. 0 times 2/3 is still 0. Oh. 2/3 of 3? No, 3 goes into 3 one time. 2 times 1 is 2. And sure enough, when x is 3, y is 2. When x is 0, y is 0. When x is -3, y is -2. So it matches up right here. That was a comma, not a 1. So, alrighty. So there are some quick examples of how we can find our intercepts, how we can graph out these horizontal, vertical lines, or lines that are going through the origin. All right, if you've got any questions, let me know, and I will see you in the next video.